Hi, sixth graders. So today we're going to take a look and break down all of our vocabulary, more so for the memory tricks. Now, if you're still confused on memory tricks are what are going to help you own these words. I do not want it that you are just memorizing definitions. I want you to own the word, meaning you're connecting it to your prior knowledge. You are taking it and connecting it to things that you know, that you love, and it's going to help you better understand each of these words. You will be asked to apply these words this year. You will not be asked just to memorize definitions. So please make sure that you are really thinking about your memory trick and changing it if you need to. Let's get started. With matter, matter is anything that has mass and takes up space. So you could literally have put anything in here. If you love football, draw a picture of a football. If you love music, draw music notes, draw a piano, draw a microphone. Make this something that is going to resonate with you so that you will remember, oh yeah, the air I breathe is matter. The soccer ball that I kicked at practice last night was matter. Make it something that you love. I put just a few things on here, like a cloud and a person, a flower, and a chair. Again, anything is going to work for matter. So let's break it down into something a little more small, and that's a substance. A substance is a single kind of matter that is pure and has a specific set of properties. So we have to be careful with substance. Substance is going to be something that is not going to change. Meaning if I go and get salt like I have pictured here, no matter what brand I buy, no matter what store I buy it in, even if its breakdown is different, whether it's small grain or large grain, the salt itself is the same thing. So it's a pure substance. I can't say the same for all things. You have to be careful with this one. If you're now thinking of things you can buy in a grocery store, you might want to go away from that and think of other things like elements on the periodic table of elements. No matter what the composition of it is going to be, it's always going to be the same. I even have to be careful with water because water that I get from my pipes might have fluoride added by the city, whereas water that I buy in a bottle at the store might not. So we have to just make sure that our substance is something that is truly pure and it's going to be the same every single place that I get it and that I use it from. Continuing on, physical properties are next one, and this is a characteristic of a pure substance that can be observed without changing it. That's our key here. We cannot change the physical properties, the substance, the object that we are observing physical property in. So, for instance, this is going to be phase changes. If we melt a block of gold, it's still gold, even if it's a puddle. If we melt an ice cube, it's still water. Or if we take that water and freeze it into an ice cube, it's still water. It's just taken on a different form. And so this could include things like going and getting your hair cut. This could include things like chopping wood or tearing up pieces of paper. We are physically altering what it looks like, but we are not changing what it is. Whereas a chemical property is changing that characteristic, that substance, into something different. And so, yes, could we clearly, like I have drawn here, use a chemical change, a chemical reaction? Absolutely. I used our vinegar baking soda experiment that we observed in our magical inflating balloon experiment. You could draw the experiment if you wanted to, but I need you to understand that chemical properties aren't always going to be a chemical reaction. It could be something like rusting. Now that is a chemical reaction, but we don't always see it that way. We see it as the rust that's happened afterwards. We don't always see the acid falling onto that piece of metal before the rust happens. This could also be something more fun, like baking cookies. A chemical reaction happens inside, and think of it this way. Can you pull the egg back out of your baked cookie once you have it cooked? No. And if you can answer no to, is it still the same object after the reaction, then it's going to be a chemical property. So always ask yourself that question after you witness something happening. Is it what it used to be? And if the answer is yes, it's going to be physical. If the answer is no, it's going to be chemical. And we'll keep looking at these when we get to our doodle. So continuing on, an atom. This is the basic particle from which all elements are made. The smallest particle of an element that has the properties of that element is an atom. And so in the most basic terms, we have a positively charged nucleus in the center. We also have our negatively charged electrons on the outside. You might have over time seen a symbol closer to this as your element. As your atom. This is kind of the universal symbol for atom. Again, it's just that one single basic piece that everything starts as. That's our atom. Now, if we start to combine those atoms, we get an element. That's the substance that contains one kind of atom over and over again, and it can't be broken down into simpler form. So everything found on the periodic table of elements, that's what I drew for my memory trick, is going to be an element. It's just a combination of the same atom over and over again, which is causing it to be pure. The only difference is we are counting how many protons and electrons we have, and that's what changes the element going from one element to another. Now, if we start to combine our elements, we get molecules and compounds. So let's look at the difference. A molecule is a neutral group of two or more atoms held together by covalent bonds. So when we breathe air in, we are not breathing in just oxygen as it is found on the periodic table of elements. We are actually breathing in a molecule called O2. And this is two oxygen elements bound together by that covalent bond. And that's the type of oxygen our body needs to survive. Okay, so there's so many different types of molecules out there. But again, it's just two or more atoms held together. Now, what turns them into a compound is a substance made out of two or more elements chemically combined in a specific ratio or proportion. So here I have put water down. And so water is just two hydrogens attached to one oxygen. You can see I use the same color, the same picture for that oxygen molecule in the middle there. And that might help us to remember the difference. You'll find in our video tomorrow a deeper conversation on the difference between molecules and compounds. Our last word here is mixture, and that's two or more substances that are together in the same place, but their atoms are not chemically bonded. So I tried to go a little bit more into what maybe we are used to for my memory trick, and I just made cookie dough. Now I have to be careful here. I need to remember that this mixture is just the substances. So the eggs, the butter, the flour, the sugar, the salt, the baking soda, and the chocolate chips. It's the dough itself. If I were to bake it, I would have caused a chemical reaction and changed it. It would no longer be considered a mixture. Right now, just as a dough, I can use it as a mixture. Now, if you can think of a better mixture that you want to use, that again is two or more substances put together at the same time, but they're not chemically bonded, feel free. If you have a cup of lemonade, there's so many other things you could add in there. So again, make these your own. If you're not sure, send me an email, ask questions. But I want you to use pictures that are going to help you own the words. So start studying these, look over these, and again, if you're unsure, let me know. Don't forget to submit when you're done.